We now need to talk about phase diagrams. You've already learned one graph, which was called the heating curve, and now you're going to learn another graph, which is called phase diagram. It tells you almost the same thing, but a little bit with a twist. With this unit, you have several graphs that you need to be able to understand, analyze, and give me information about it. Okay, so phase diagram is literally what it means. It shows you the different phases of a chemical. But this time, instead of being like a straight few lines or whatever, you get this weird look to it. You sort of get these three lines that sort of meet somewhere in the middle. On your x-axis, you have change in temperature. On your y-axis, you have pressure. So it's this relationship between pressure and temperature. Now what happens is these three lines represent phase changes. Okay, so at very low temperatures, you would think that you would have a what? You would have a solid. So in this area, anywhere between this area here with these pressures and these temperatures, you're going to have a solid. Now, this section, the temperature gets a little bit higher, but pressure still stays a little bit above normal or above this point here. This is where you have your liquids. Now, if you were to drop the pressure dramatically and increase the temperature, you get your gases. Okay, so you need to know everything here is a solid, everything in this area is a liquid, and everything in this area is a gas. If you have a point that's on the line, so for instance that point there, this is your actual phase change occurring. So it's a solid and a liquid. They're at equilibrium. So what happens here, where all three parts of the graph meet, this is called your triple point, where solid, liquid, and gases literally are coexisting. They're in equilibrium at that point. Now, there is a point where you get where the temperature becomes so high and the pressure becomes so high, you get a critical point. You're not able to see or notice the difference between the gas and the liquid. It can no longer happen. Okay, so like I said, it shows us the phase changes. So you have to know those phases. We've already talked about 4 of them. We haven't really talked about the last 2. So you need to make sure that you know them. Okay? So as you go this way, as you cross over, because remember this is solid, liquid, and gas. As you cross over in this direction, going from a liquid to a solid, it's freezing. As you go the opposite direction, it's melting. Condensation and vaporization, going from a liquid to a gas. And then lastly, deposition and sublimation. So sublimation means you go straight from being a solid to a gas. The most common example for that one is dry ice. And deposition is the opposite. Okay? Now, the last part that you need to make sure you know is if I give you this graph, you've got to be able to tell me what happens at 1 atm. This is going to be the key thing here. At 1 atm, you have to know that when it crosses this line here, at 1 atm, that tells you you're melting in freezing point. So you find 1 atm, find where it crosses this line, and you get that point. Also at 1 atm, if you keep on going and cross this line, whatever temperature's here gives you the boiling point. Okay? Now, one last thing about this is this line is extremely important when dealing with density. If it slants to the left, okay, if this line slants to the left, what does this mean? This means that your solid is less dense than your liquid. So if this line slants to the left, for this one for example, that means your solid is less dense than your liquid. So when you put that solid into the liquid, that means it's going to float. So an example of this is water. This is the actual phase diagram for water. Now, what if it doesn't slant to the left? What if we had a graph that did that, meaning it slants to the right? So if it slants to the right, it's the opposite. The solid is more dense than the liquid. So the solid will go to the bottom of the container. Okay? A lot of different things that you need to know about this one little graph. Who knew it could? It looks so simple, but it tells you tons of information. Okay? Now, just to go over some keywords that I've already mentioned, you just need to make sure you know the definition. Critical point is the temperature and pressure beyond which it is impossible to distinguish the liquid from its vapor. triple temperature and pressure, the three phases coexist. Normal boiling point, key thing there is going to be that 1 atm. It's the temperature at which the liquid boil at 1 atm. Freezing, same thing, happens at the 1 atm. Okay? So you have to know all these different definitions, and you have to be able to tell me every little thing that I've told you about that graph in those pictures.